All right. So future value, basically it's going to be the principal plus our interest. So if again we borrow a principal or whatever and we call that P and it's borrowed at a simple interest rate of R, and again we have to convert that to a decimal, then after T years the amount due is going to be A. And that can be determined as follows. A, future value, is going to be the principal plus any interest that we gain. And what is interest? Well, if you remember, interest is P times R times T. So really we have P plus P times R times T, but we like to make things a little more simpler in math. And so what we're going to do is we're going to factor out that P, and then we'll have P times 1 plus RT. And so that makes it a lot easier to plug in your calculator and kind of to remember. And so now all we have to do is we have to remember, oop, whoa, we have to remember the P value, the R value, and the T value and plugging them in. All right, so calculating the future value for simple interest, again, future value is the A, P is how much the principal is for the thing, rate is going to be a decimal, T is going to be time in years. Okay, now how should I round when finding present value? Well, the key thing is when computing these, you want to round up, okay? Because if you round down, then you're not going to have enough. And so basically add one to the hundredths digit, regardless of the digit to the right. And this way you'll be sure to have enough money to meet your future goals. Otherwise, it's not going to work out as far as calculations go. All right, so let's say we have, in this case, a loan of $2,040 has been made at 7.5% for 4 months. Find the loan's future value. Okay, so here is a couple things. Remember, we have to convert this to a decimal, 0.075. These have to be in years. Well, 4 months is going to be equal to what? Well, what we have to do is we have to do a conversion. There's going to be 12 months in 1 year. And so that's going to be 4 divided by 12. It's going to be really what we're going to use there. So our number is going to be 4 over 12. And I'm just going to leave it as that because I can plug that in my calculator. That's really just 1/3. But that way I remember why I have 1/3 here. It's because I had 4 months out of 12 months. Okay. So the loan's future value. So again, A is equal to P times 1 plus RT. Future value is going to be equal to, well, that's going to be 2040, the loan amount, times 1 plus 0.075 times, again, I'm going to use the 4 over 12. Now I'm going to plug all that into my calculator. And when I do that, I'm going to have 2040 times 1 plus 0.075 times 4 divided by 12, and that gives me 2091. So that's going to be my future value on the $20.40 or $2,040. All right, so that was 2091. So that's my future value when I have 7.5% interest for 4 months. Okay. And again, the key is it said 4 months, so we have to convert that months to years, and that's going to be 4 divided by 12. All right, so the next one. In addition to jeopardizing your health, cigarette smoking is a costly addiction. Consider, for example, a person with a pack-a-day cigarette habit who spends $7 per day, 7 days each week on cigarettes. How much is spent on this item each year? All right, well, we're going to have how many $7 per day? So $7 per day. How many days are there in a year? Well, there's 365 days per year. So that's going to be multiply those two together. So it's going to be 365 times 7. So that's going to be 2,555. So that's going to be $2,555 per year. So that's how much they spend on cigarettes per year. Now it says if this person was smart instead and invested the amount they spent on cigarettes instead into a savings account with even a small interest rate of 1%, how much should be saved after 1 year? All right, so that means we're going to use our future value. And so that's going to be 2,555 times 1 plus our rate, which was 1%, so that's 0.01, times the time. Well, that was just 1. So now we're going to plug all that together. So we'll have 2,555 times 1 plus 0.01 times 1, parenthesis. And so $2,580.55. So that was $2,580.55. So they would actually ended up with more money if they would have actually put it into savings instead of spending it on cigarettes. So that's kind of how much it is. It's not a lot because well, A, we have a very low interest rate. So maybe if that was a 7%, that would be a bigger number. So what would it be if we had a 7% interest rate? Let's do that. So if we bring up our last equation and we had a 7%, we'd have $2,733.85. So you can see, it gives us a lot more interest obtained when we have a higher interest rate. So the better interest rate you can find, the better it is. Now it's opposite when you borrow. When you borrow, you want the lowest interest rate as possible because then you have to pay back less. So if you had to pay back the interest on both of these, you'd have to pay them a lot more back if you had the 7%. So it kind of works opposite of each other there. All right. So let's say we want to borrow 5,000 from a friend and promise to pay back $6,800 in 2 years. What simple interest will you pay? All right, so we're going to go back into A equals P times 1 plus RT. Well, our future value is $6,800. Our present value is 5,000. 1 plus our rate. Well, guess what? That's what we're looking for. What simple interest rate we're going to pay. And in time of 2 years. Okay, so times 2. That's a times. Okay. So we need to solve for R. So we have to do some algebra. All right. So first things first, we're going to divide by 5,000. And when we do problems dealing with financial stuff or anything like that, we don't divide or do anything out else until the very end. We plug it into our calculator as a whole equation, and we tell the calculator to give us answers. Otherwise, if we do pieces, like if I take the 6,800 divided by 5,000 and I round that number, and then I start doing all these other calculations and do a lot of rounding. If we're talking millions of dollars, you might be off by hundreds of thousands of dollars, which is quite a bit. When we're off here by, a few cents or whatever, it doesn't seem like a lot, but when you start adding that into if you're working at a big corporation and you're doing millions of dollars, then it really starts affecting your bottom line. So we're going to keep numbers as a whole number as we have them and just type it into our calculator because that's easy to do. All right, so then that's going to be 1 plus 2r. All right, so now I need to solve for r, so I subtract 1 from both sides. So now I have 6,800 over 5,000 minus 1 equals 2r. Now, how do I get rid of that? Well, if I multiply by half, those two cancel and I have r. And so I multiplied that whole thing by half. And so now if I plug this into my calculator, I'll get the right answer. All right, so I'm going to take that half times, I had 6,800 divided by 5,000 minus 1, parenthesis, and I get 0.18. So in this case, my rate is 0.18 as a decimal, and if they want it as a percent, we move it 2 places to the right and add a percent sign, so that would be 18%. So that is my interest rate that I'm going to pay for that borrowing of the money from my friend. All right, so one last one here. How much should you put in an investment paying a simple interest rate of 3% if you need $4,000 in 6 months? All right, well, all right, so I know I need 4,000 in 6 months. So again, if we write down what we have, 1 plus RT, A needs to be 4,000. P is what we're looking for. 1 plus, now my rate, that's going to be 0.03. Now 6 months, well, remember, 6 months is going to be 6 out of 12. It's going to be half because it's going to be half a year. And it kind of goes things like we did before. If we took 6 months and then we multiplied it by 1 year is 12 months. And so then what happens is those months cancel. And so we have 6 over 12 parts of a year. So half a year is what it turns out to be. All right. And that kind of looks funny there, but that's okay. We'll erase a little bit there. So that's a half. All right, so now I need to solve for p, so I'm just going to divide by 1 plus 0.03 times 1 half, and I'm going to divide that side by 1 plus 0.03 times 1 half. Now, I would suggest putting parentheses around everything because what happens is if you just take 4,000 divided by 1 plus this, you're just going to take 4,000 divided by 1, which is 4,000, and then add 0.03 times a half, which is not what we want for an answer. And so if we do this problem instead, let's clear all this. We have it at the top. We have 4,000, and then we divide by, and parenthesis, and then we had our 1 plus 0.03 times a half, and in parenthesis, and we get $3,940.80, and we're going to round that up to 89 cents. Okay. Now, I want to show you what the difference is, though, if we didn't put those parentheses in there. And say we just did this. Much different problem. And so that's why what happens is when you take this divided by this, calculator does order of operations. So it's going to do this division first, then it's going to add, and then it's going to add the product of these two together. And so that's why you get a different number. So the second one's wrong, just that first one's right because I remember to put the parentheses there. So that's just to kind of show you parentheses really matter here when you're typing into your calculator. So be sure to watch out for that there. So we have 3940.89 after we did that rounding of the 88 up, 8867 or whatever, up to the 89. So that would be our value that we need to invest to get to $4,000. Now, if I was thinking about it, and the other one was I had to put in $4,000 and so many cents to get out $4,000, that doesn't make sense. So that's another thing. You have to look logically, does it make sense the value you get out? And if it doesn't, then you've probably done something wrong in your calculation. Most likely a set of parentheses, I would say. All right, so that finishes up this section. Hopefully that will help you on the problems.